Pushing a hat. Who can raise their hand and tell me how much force is the child using to push that hat? Anwar, how much force do you think it's using to push the hat? 10 newtons of force. And how far, for a ticket, how far is he pushing that hat? How far is he pushing the hat? Miro. Close, not 3 miles. The little lowercase m stands for, Frankie?
Meters.
Meters, good. Who remembers how to calculate the amount of work done? Okay, 2 of you, that's okay. 3 of you, 4 of you. Just a little reminder, on the bottom, underneath Andrew, the picture, the formula to calculate work is force times distance. So how do you calculate work? Hurry up.
Force times distance also, which you could also say as newtons times meters.
Good. Newtons times meters. So I want you to take about 30 seconds. Raise your hand when you think you've calculated how much work this triangle is doing to the hat. So go ahead and fill that out now. You need to fill it out on your sheet.
I did.
How much work, and when you're done, raise your hand. Let me see. Put your hand up in there. I won't walk around. When you think you have an answer, put your hand up. I see all of you guys have answers, but I don't see a couple hands up. Andrew, what did you get? How much work did the triangle do to the hat?
In total?
Yes, in total.
30 joules.
30 joules. What did you get, Anwar? 30 joules. Mirabel, what did you get? 30 joules. Uriel.
30 joules.
Alberto. What did you get, Junior? 30 joules. Who wants to tell me how they got 30 joules? How did you calculate 30 joules of work done? What was that? Good. 10 times 3, which was what times what? Junior. What does a 3 represent? 3 what? Hot dogs, pineapples. 3 what? Uriel.
3 meters times
And what's the
10
10?
newtons. 10 newtons.
10 newtons, which is what, Junior? What's that? Okay. So,
10 newtons of force.
now we're ready, and for those of you in the back waiting to see, we're almost ready. To see the actual game, the triangle game, called push, ready to do some work. The packets need to be off the mats, and once I see all the packets off the mats, we'll turn off the lights, and you will be amazed.
I don't scream the troubles.
Okay? 3, 2, 1. Okay. Now I'm going to need 4 volunteers. I need 4 quiet volunteers from the class. Okay? This right here is the controller for Small Lab. This is what it recognizes. It doesn't recognize me. Yeah, I said I need a quiet volunteer, so if you're talking, chances are you won't be picked as a volunteer. This is what it tracks. So you'll notice when I move this around, it follows me. It can also tell the difference between when it's up here and when it's down there. So in order to get this game started, you're going to need to cut all of the strings. Okay, and the way you cut a string, this is the core mechanic, the motion that does it. Because if I just walk like this, nothing is going to happen. However, if I go like this and I go down, it cuts it. Okay, so I'm going to need a volunteer to stand here. Frankie. Hold it like this so you don't block the spheres. Go ahead. Excellent. I'm going to need a volunteer to be over here. Ethan, come on up. Do not start cutting any strings until I give you the direction to do so. Okay. Anwar over here. And Tyrese. Why don't you come on? Okay, one of our 7th graders from last year. All right. Okay, so now when I give you the instructions, to remember, the core, do not do it yet, the core mechanic is to go like this tell you to, you may cut all the strings and the game can begin. Go. Remember the motion. Alright, now, place the controllers along the edge here, gently on the floor.
Oh, this is Jeopardy.
Alright, now please flip in your packet to the page that looks just like this. There's a page in your packet, should be right on the back of the first page. Looks just like this.